నేను ఇక్కడ హ్యాబిట్స్ వచ్చినప్పుడు సహాయం చేస్తాను.
मैं क्या बोलता फैकल्टी नहीं है दिमाग नहीं बोल रहा हूँ. गुड मॉर्निंग सर. ओके हेलो ना मनीष गारू हमारी सो क्या करना है देखो ये डबल क्लिक करना है इस पे इसको डबल क्लिक करके इसको करें तो याद होता है तो डबल डबल आता है इसको भी ओपन नहीं कर रहे ठीक है पीछे क्या ज्वाइन हो गया तो मीटिंग ज्वाइन है. हाँ ज्वाइन हो गया. हाँ पार्टिसिपेंट 600 बता रहा हूँ इस पे ज्वाइन से हमारे ना ज्वाइन से ये भी जरूरत नहीं हो पहले तो इसकी क्या करें डबल क्लिक है तो ये है ना वैसा आता इसको डबल क्लिक करके फिर ये सिंगल पे मारना तो ये सिंगल आ जाता है. नहीं मलेश गौर ये मैसेज का सेटिंग मार दी. हाँ मैसेज का सेटिंग मारे अरे ये मैसेजेस को यहाँ मारना जैसा फर्स्ट तो एक दूसरे को मैसेज डाल लेते रहते तेरा नंबर क्या है तेरा नंबर क्या है ये नहीं कर रहा. यूट्यूब लाइव आ गया ना देखो चेक करो एक बार. रणजी मले सर वेलकम. మనం ఇక్కడ నుంచి కంటిన్యూ సార్ బ్యాచెస్ ఆన్లైన్ కానీ ఆఫ్లైన్ ఓకే విల్ కీప్ యూ పర్మనెంట్లీ స్టూడెంట్స్ ఆర్ సాటిస్ఫైడ్. अरे कौन है जी हेलो में लगी भी इसको उल्टा लगा तो वैसा लगाना ये इसमें जाके अटक जा रहा हूँ खाली ऐसा लगाना है. देखो उसको सिखाओ उसको आने के बाद हो क्या हुआ फिर फादर मैसेज होता हूँ कितने दिन फादर अपॉइंटमेंट रहता है एक हफ्ता अपॉइंटमेंट रहता है इसको अंदाजा नहीं है डायरेक्टर को मालूम है ना बुला के पूरी गिन देते हो टमाटर का नाम मैं कहीं को बोल के जानवर के बचा दे रहा हूँ सर थैंक यू white again this one color changes whatever color you want get this one we can write clear అని తెలుసు ఓకేనా కనీసం ఇది పైకి చేసుకోండి కొంచెం మీరు రాసినది క్లియర్ కదా అన్ని క్లియర్ ఉంది క్లియర్ అయితే క్లియర్ అందుకని వచ్చేస్తుంది ఓకేనా పైకి తీసుకోవాలంటే ఇక్కడ నుంచి ఇది మీకు మొత్తం వేరే ఉంటుంది ఇది పైకి తీసుకోవడం మీద అవసరం లేదు పైకి వచ్చేసింది రాయండి క్లియర్ మళ్ళీ కింద చేసుకోండి మళ్ళీ ఓకే.
Good morning to all. So in last class we have started physical quantities and measurements, and in this class we are going to learn about acceleration due to gravity. So then what is acceleration? Then acceleration due to gravity. Acceleration, let us learn. Acceleration. If any object is changing its velocity, then the object is said to be accelerated. It is represented by A, acceleration. So acceleration is nothing but the rate of change in velocity of the object is known as its acceleration. So that is rate of change in velocity of the object is known as acceleration. So object is under acceleration means that is rate of change in velocity. Rate of change in velocity. Change in velocity of the object is known as its acceleration. The rate at which the object is changing its velocity. Velocity. An object is changing its velocity means it is under acceleration. The rate at which the object is changing its velocity is known as acceleration. For example, whenever we are going on a bike, let our speedometer is 0, 10, 20, 30, speedometer of the bike. Means speed of the bike is increasing, then it is said to be it is under acceleration. The rate at which it is changing its velocity. Change means it is increasing velocity or decreasing velocity. Or increase in velocity is said to be positive acceleration. Decrease in velocity is said to be negative acceleration. Suppose whenever we are going on a bike, our speedometer starts from 0, 10, 20, 30 like that. Speed is going on increasing. Now it is said to be positive acceleration. The rate at which the velocity is increased, each and every second, how much it is increasing, that is known as positive acceleration. The rate at which the velocity is going on decreasing, then it is known as negative acceleration. So, object is under acceleration means there is change in velocity. The rate of change in velocity of the object is known as acceleration. So, that is acceleration A is equal to acceleration A is equal to, now we can write change in velocity by time. A is equal to rate means we should divide by time. That is change in velocity by time. In velocity by time. In velocity by time. Velocity by time should be divided by time. That is change in velocity by time. By time, we should divide by time. When do we change? There is change in velocity is nothing but final velocity minus initial velocity. That is equal to change in velocity by time. That is change in velocity, final velocity v minus initial velocity u by time t. By time t. So that is acceleration A is equal to, we can write A is equal to v minus u by t. We can write A is equal to v minus u by t. V minus u by t. So that is acceleration A is equal to v minus u by t. We can write v minus u by t. A is equal to v minus u by time t. So that is acceleration A is equal to. U is represented by initial velocity, and initial velocity is represented by u. Final velocity can be represented by v. U, v will come in alphabetical order in English. So u first, then v, u, v, w, x, y, z. So that is acceleration A is equal to v, that is nothing but final velocity minus initial velocity by time t. Suppose whenever we are going on a bike, our speedometer first it is on 20. After few seconds, let it turns to 50. What is the change in velocity? 50 minus 20. 50 is the final velocity, that is v. And before the initial velocity was 20, that is u. V minus u by t. Then what are the units for acceleration? Units for acceleration. Units for acceleration. So what are CGS units? and MKS units, CGS units. In CGS system, it can measure centimeter per second square. MKS system, that is meter per second square. MKS system, meter per second square. Suppose an object is starting from rest. Object is starting from rest. Suppose an object is going like this. Let its initial velocity 0. If any object is starting from rest, then its initial velocity will be 0. That is u is equal to 0. U is equal to 0. Let exactly after 1 second, let its velocity is like that. After 1 second, its velocity is 2 meter per second. Let it be. After more 1 second, let it be 4 meter per second. After more 1 second, let its velocity is 6 meter per second. Its velocity is increasing, decreasing, or remaining constant, increasing. Each and every second, how much it is increased? Here, change in velocity is here in first second. The change in velocity is here. That is 2 meter per second. That is 2 meter per second is increased. And here 4 to 2 to 4 it has become. That is here also it is increased by 2 meter per second. 2 meter per second it is increased. Here also it is increased by 2 meter per second. This 2 meter per second is increased. This 2 meter per second or 2 meter per second is increased. Within what time this 2 meter per second is increased? This 2 meter per second is increased. 2 meter per second is increased for every second. That's why it is 2 meter per second per second. That is also written as 2 meter per second square. 2 meter per second square. This is the acceleration produced in the object. 2 meter per second square is the acceleration produced in the object. So therefore, and MKS units for acceleration is meter per second square, whereas CGS units is centimeter per second square. Now, suppose if an object is next, let us learn about freely falling object. What is freely falling object? If any object is falling to the ground without applying any external force, then it is known as a freely falling object like this. If any object is falling to the ground without applying any external force, then it is known as a freely falling object. It is known as a freely falling object. If any object is falling to the ground without applying any external force, that is known as freely falling object. Let it be like this. This is known as freely falling object. What is the initial velocity of freely falling object? The initial velocity of freely falling object will be, initial velocity of freely falling object will be 0, since it is starting from rest. Initial velocity of the object will be 0. Therefore, initial velocity can be represented by u. Let it be exactly after 1 second. Then the velocity, what will be the velocity of freely falling object? Exactly after 1 second, it is 9.8 meter per second. 9.8 meter per second. After more 1 second, its velocity will be, how much it will be? More 9.8 is increased. That is 19.6 meter per second. 19.6 meter per second it is. 19.6 meter per second. After more 1 second, its velocity will become more 9.8 is increased. That is 29.4 meter per second can be increased. 29.4 meter per second is increased. So the velocity of freely falling object can be increased by 9.8 meter per second for every second, and it is with respect of the mass. The initial velocity of freely falling object is 0 exactly after 1 second. Suppose if any object is falling like this, if any object is falling, its initial velocity will be 0 exactly after 1 second, then its velocity will be 9.8 meter per second. Therefore, the velocity, and after more 1 second, and it is with respect of the mass. It is independent of the mass. So the velocity of freely falling object can be increased by 9.8 meter per second for every second, irrespective of the mass. The velocity of any freely falling object can be increased, irrespective of the mass. Therefore, if its initial velocity is 0, exactly after 1 second, it will be 9.8 meter per second. Therefore, the velocity of freely falling object can be increased by 9.8 meter per second for every second. and irrespective of the mass, that is, irrespective of the mass, the velocity of freely falling object can be increased by 9.8 meter per second for every second. So that is due to gravity. It can be increased due to gravity. Therefore, its velocity will be increased. This 0 to 9.8 is increased. No, within what time it is increased? That is, it is increased within 1 second. Therefore, 9.8 meter per second for every second it can be increased. 9.8 meter per second for every second, that is 9.8 meter per second is increased, and for every second 9.8 meter per second is increased. Every second it can be increased. And here also, next second also, so that is in 1 second it has come from 9.8 meter per second here in 1 second, that is. And next second also it has brought up in 1 second, next 1 second it is 9.8 to 19.6. Here also 9.8 meter per second is increased. 9.8 meter per second is increased every second. 9.8 meter per second is increased every second. So here also, and next second also, velocity is increased by, in 1 second, it is 9.8 meter per second is increased. 9.8 meter per second is increased, and that is for every second. Therefore, it is also written as every second. It is also written as, that is 9.8 meter per second square. 9.8 meter per second square. This is the velocity is increased by 9.8 meter per second for every second. Suppose the velocity of freely falling object can be increased. Why is it increased? Why? Because it is under acceleration. So velocity can be increased means it is said to be under acceleration. Why is it under acceleration? Why? Because Earth is attracting towards it. Earth's attraction force is also called gravitational force. Because of gravitational force, the velocity can be increased. Therefore, it is said to be under acceleration. That is due to gravity. Acceleration due to gravity and represented by small z. Therefore, why do we take small z is equal to 9.8 meter per second? Because of this reason. Small z is equal to 9.8 meter per second. That is due to gravity. That's why we take small z is equal to 9.8 meter per second for every second. Therefore, small z is equal to, we take it as small z is equal to 9.8 meter per second for every second. That's why 9.8 meter per second square. That's why we take small z is equal to 9.8 meter per second square, because of this reason. This is the reason behind it. Why do we take small z is equal to 9.8 meter per second square? This is the reason behind it. So therefore, the velocity of freely falling object can be increased by 9.8 meter per second for every second, and that is due to gravity. And it is irrespective of the mass. Therefore, if 1 kg and 10 kg objects are dropped from same height, both will reach at a time. Why? Because both the velocities will be, initial velocity will be 0, both are starting from rest. Exactly after 1 second, the velocity of each object will be 9.8 meter per second, and it is independent of the mass. It is irrespective of the mass and 9.8 meter per second. After more 1 second, its velocity can be increased by more 9.8. Therefore, it becomes 19.6. Next second, 29.4 meter per second. Therefore, the velocity of any freely falling object will increase by 9.8 meter per second for every second. That is due to gravity. And it is independent of the mass. It will not depend on the mass of the object. Therefore, whenever 1 kg and 10 kg are dropped from same height simultaneously, therefore both will reach at a time. And this was experimentally conducted by Galileo, not now in 16th century itself he proved that, and this experiment was conducted in presence of the public and on the interest of the public. It took 2 iron spheres made up of iron, solid spheres without emptiness inside. One is 1 pound, the other is 100 pounds. So 1 pound is little less than half kg, and the other is 100 pounds, approximately 45 kgs. One is 100 times the other. So we made to drop from the top of the 3-story building. So both have reached at a time, irrespective of the mass. Why? Because the velocity of freely falling object will be 0, initial velocity, exact after 1 second, 9.8 meter per second. And each and every second, the velocity of object can be increased by 9.8 meter per second for every second. That is due to gravity. Therefore, acceleration due to gravity is equal to 9.8 meter per second square. That is small g is equal to 9.8 meter per second square. So that's about acceleration due to gravity. Now, let us learn about the other topic, universal gravitation. Let us learn universal gravitation. Universal gravitation. Universal gravitation. Next topic is universal gravitation. And in this, we are going to learn about first geocentric theory. Geocentric theory. And this theory was proposed by Ptolemy in 2nd century AD. Ptolemy, 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 and was proposed in 2nd century AD. This was proposed in 2nd century AD. 2nd century AD. According to this theory, all the planets PTO, P silent here, and according to this theory, all the planets are revolving around the Earth and Earth as a center. Therefore, the theory is known as geocentric theory. In Greek language, geo means Earth. Earth as a center, all the planets are revolving around the Earth. Therefore, the theory is called the geocentric theory. Then, geocentric theory. Then, that is about geocentric. And this theory was believed by the people up to 16th century AD. So, suppose if you watch the sun appears to be rising in the east, revolves around the Earth, sets in the west. And also some moon and some other planets and natural satellites and stars may be appearing revolving around the Earth. Might be keeping such incidents, he might have proposed that theory. Therefore, the theory is called geocentric theory. Next one is then heliocentric theory. Second, heliocentric theory. Heliocentric theory. Heliocentric theory. So this theory was proposed by Copernicus in 16th century AD. This theory was proposed by Copernicus. Copernicus proposed this theory. This theory was proposed by Copernicus in 16th century AD. Copernicus. The name of this scientist, Copernicus. This theory was proposed by Copernicus in 16th century AD. 16th century AD. According to this theory, all the planets are revolving around the sun and sun as a center. In Greek language, geo means Earth. Earth as a center, all the planets are revolving around the Earth. Therefore, the theory is called heliocentric theory. And so when whenever you propose this theory, means here in solar system, Earth is also one of the planets in the solar system. Therefore, Earth is revolving around the Sun. Not only the Earth, remaining all the planets are revolving around the Sun and Sun as a center. But whenever you propose this theory, not only common people, even scientists could not believe in this theory. Why? Because so Sun appears to be revolving around the Earth. Sun rises in the east, revolves around the Earth, sets in the west. Therefore, might have, but he said that the Earth itself is revolving around the Sun. Not only the Earth, remaining all the planets are revolving around the Sun, and it proved in practical. Then afterwards, after Copernicus, and it was Tycho Brahe who started his research. Tycho Brahe started his research. Tycho Brahe. Tycho Brahe started his research. Tycho Brahe is the name of the scientist who proposed the theory. So whether the planet is revolving around the Sun or Sun around the Earth, based on this concept, it started his research. So that is Tycho Brahe started his research based on this concept. But unfortunately, passed away in the middle. Then his disciple John Kepler, John Kepler, his disciple John Kepler continued his theory. Then, first of all, John Kepler completely supported Copernican theory. Means John Kepler said that Copernican theory or heliocentric theory is right. All the planets are revolving around the Sun and Sun as a center, according to him. Sun and Sun as a center. Therefore, he proposed this theory. And also, Kepler also proposed the laws of planetary motion. Who proposed the laws of planetary motion? The question was given in so many competitions. Laws of planetary motion. Laws of planetary motion. Who proposed the laws of planetary motion? Asked in so many competitive examinations, SSC and Group 1, Group 2, and Constable. The question was given in so many competitive examinations. John Kepler proposed the laws of planetary motion. Then let us learn about variation in small g value. How does the small g value varies? Variation in small g value. Variation in small g value. Variation in small g value. Does small g value change? Suppose from equator towards the poles. That is, how does it vary from equator towards the poles? So whenever we go from equator towards the poles, small g value gradually increases from equator towards the poles. From equator towards the poles. So that means at the equator, the small g value lies. Small g value will be minimum. It will be. Then how much will it be? 9.78 meter per second square. 9.78 meter per second square. Small g value will be at the equator. That will be 9.8 meter per second square. So it is not going to be 9.8, but 9.78 meter per second square. it will be 9.78 meter per second square. Small z value will be 9.78 meter per second square. Small z value. At the equator, it will be minimum. And at the poles, it will be maximum. Small z value at the poles will be maximum. Poles will be maximum. Small z value at the poles, it will be maximum. Small z value will be maximum. That is how much it is. Maximum means 9.82 meter per second square. 9.82 meter per second square. Therefore, we take neither 9.78 nor 9.82. Therefore, we take it as 9.8. Therefore, the weight of an object means the gravitational pull will be less at the equator and more at the poles. Therefore, acceleration to gravity at the equator it will be 9.78 meter per second square, whereas at the poles it is 9.82 meter per second square. Therefore, we take small z value as neither 9.78 nor 9.82, but we take the average of these two. That is 9.78 plus 9.82 by 2. That is 9.80 or 9.8. That's about the small z value at the equator, that on the Earth. So similarly, the weight of the object also minimum at the equator. Why? Because the small z value will be less at the equator means gravitational pull will be less at the equator. Means Earth attracts little less at the equator, and Earth attracts little more towards it at the poles. Now, what is the weight? Weight is nothing but gravitational force acting on the object is called its weight. Whatever the gravitational force acting on the object is called its weight. So, Earth is attracting at the equator lesser force means the weight of the object will be minimum at the equator. Therefore, the weight of the object will be minimum at the equator. Weight of the object will be minimum at the equator. Weight will be minimum at the equator and minimum at the equator. At equator. And weight will be maximum at the poles. Weight will be maximum at the poles. At poles, the weight will be maximum. Maximum. And this like this from equator towards the poles, small z value gradually changes. That suppose if you go up from the surface of the Earth, what happens? From that is B bit, A, B we have learned, A regarding A. Now B we are going to learn. From equator towards the poles. From and to a height from the surface of the Earth. To a height from the surface of the Earth, what happens? B. Height from the surface of the Earth. Surface of the Earth, what happens? What happens? We go up from the small surface of the Earth, small g gradually decreases. Small g value decreases gradually. Going on decreasing means somewhere it will be zero, no? At which height it will be zero. Therefore, small g value since gradually decreasing, therefore the value of small z will be zero at the height is equal to half of the radius of the Earth. Half of the radius of the Earth. Suppose the radius of the Earth at the equator, radius at the equator, or is the radius of the Earth at the equator, it is 6,358 kilometers. Whereas at the poles, that is at the equator, 6,382 kilometers. I'm sorry. Small z value gradually decreases. Gradually decreases means somewhere it will be zero, no? At the height is equal to the half of the radius of the Earth. Small z value will be zero at the height. Small z value will be zero. So Earth is not uniform. The radius of the Earth is not exact, but the radius of the Earth gradually increases from equator towards the poles. Where the radius of the Earth is at the equator is, it is radius of the earth is, it is 6,382 kilometers. 82 kilometers. Whereas radius at the poles is, at poles will be 6,358 kilometers. So, and approximately 6,400 kilometers it is. At the equator or poles, it will be, we can take approximately. Then at the height is equal to the half of the radius of the earth, small g will be 0. Small g gradually decreases based on altitude. Therefore, at the height is equal to the half of the radius of the earth, small g will be 0. At the height is equal to the half of the radius of the earth, small g will be 0. Therefore, height is equal to the half of the radius of the earth, small g will be 0. Height is equal to the, small g will be, radius is equal to the, height is equal to the half of the radius of the earth. H is equal to r by 2. They implies then small g will be 0. Means approximately if you go to the radius of the earth is maximum 6,400 kilometers at the equator. That is 6,382 is nothing but approximately 6,400. Then what is half of 6,400? It is 3,200 kilometers. At the height is equal to the half of the radius of the earth. Then small g value will be 0. Height is equal to the half of the radius of the earth. Then small g value will be 0. Small g value will be 0 at the height is equal to the half of the radius of the earth. Small g value will be 0. Small g value will be 0. So, radius of the earth is approximately 6,400 kilometers. What is half of 6,400 kilometers? Half of 6,400 kilometers is, it is 6,400 kilometers. Half of the 3,200 kilometers is. At 3,200 kilometers, small g value will be 0. Small g value will be 0. Small g value will be 0. So, small g value will be 0. The height is equal to the half of the radius of the earth. Then small g value will be 0. Small g value will be 0. The height is equal to the half of the radius of the earth. Small g value will be 0. Therefore, then what about the other factors? So A, B, C. Then if you go down from the surface of the earth, small g value gradually decreases. If you go down from the surface of the earth, small g value gradually decreases. If you go down from the surface of the earth, small g value gradually decreases. Small g value decrease means at the height is equal to the half of the radius of the earth. This will be 0. At the height is equal to the half of the radius of the earth. Then if you go down from the surface of the earth, small g, that is c, depth based on the depth from the surface of the earth. If you go down based on the depth from the surface of the earth, like this, if this is the earth, now if you go down into the earth's crust, go down, then what happens, small g value gradually decreases based on altitude. Based on altitude, small g value gradually decreases. Based on depth, small g value gradually decreases. Gradually decrease means somewhere it will be 0, no? Exactly at the geocenter, small g value will be 0 at geocenter. If this is the center of the earth, this is the center of the earth, it will be 0 at the geocenter. Small g value will be 0 here at the center of the earth. Small g value 0, weight will be also 0. Therefore, at the center of the earth, based on depth, small g value gradually decreases, and at the center, so center, at geocenter, small g value will be 0. At the center of the earth, small g value will be 0. Small g value will be 0. At the center of the earth, small g value will be 0. At the center of the earth, small g value will be 0. Next, what are the other factors that can affect small g value? Other factors, those which can affect the small g value. What are the other factors? Other factors that can affect small g value. So, based on that is mountains. Based on mountains, small g value will be slightly changed, very little bit. And also historical monuments. Based on historical monuments, small g value will be monuments. Small g value will be little bit changed, very little bit it is changed, slightly. Historical monuments, and also based on mountains it can be changed, and based on oceans it is changed, and based on geographical deposits, small g value will be geographical deposits. Small g value will be little bit it is decreased. Deposits, little bit, very slightly it changed. Very lightly it changed. Next, let us learn about what is atmosphere. Next topic, we are going to start atmosphere. So atmosphere is composed by air, water vapor, and dust particles. The composition of the atmosphere is done based on, that is, air, water vapor, and dust particles. All this together is known as atmosphere. Air, water vapor, and dust particles. All this together is known as atmosphere. Air, water vapor, and dust particles. All this together is known as atmosphere. At normal atmospheric conditions, the percentage of water vapor in the atmosphere will be 1.4% of water vapor will be there. 1.4% of water vapor will be there in the atmosphere at normal atmospheric conditions. All this is known as atmosphere, and this atmosphere is composed in different layers. Atmosphere is composed by different layers. These layers will exert the pressure on the surface of the ground. All these layers can exert the pressure. These atmospheric layers will exert the pressure on the surface of the ground. That is known as atmospheric pressure. Atmospheric pressure. Atmospheric pressure is nothing but the pressure exerted by these atmospheric layers on the surface of the ground is known as atmospheric pressure, and this atmospheric pressure can be measured by using barometer. And atmospheric pressure can be measured by using barometer. Barometer. Barometer was constructed by Torricelli. The name of the scientist who constructed a barometer was Torricelli. This was Torricelli. It consists of a thicker glass tube of length approximately 1 meter. Length of the barometer will be approximately 1 meter, but its diameter will be exactly 1 centimeter. And it is closed at one end and opened at the other end. Closed at one end and opened at the other end. It is closed at one end and opened at the other end. It is closed at one end and opened at the other end. Closed at one end and opened at the other end. like this. It is closed at one end and opened at the other end. From the open end, it is to be filled up with mercury. It can be filled up with mercury. From the open end, it is filled up with mercury. Filled up with mercury. And the level of mercury in barometer at normal atmospheric conditions will be, it is 70 centimeters. Now this glass tube is filled up with it consists of a thicker glass tube of length approximately 1 meter, but diameter exactly 1 centimeter. Consists of like this. Then consists of a thicker glass tube, and it is like this, closed at one end and opened at the other end. And from the open end, it is to be filled up with mercury, and it is inserted in glass tube. It is to be filled up with mercury and inserted in another glass tube. Inserted in another glass tube. In another container which consists of some mercury. Which consists of some mercury. That is. Which consists of some mercury. And it is to be filled up with mercury. Then the level of mercury at normal atmospheric conditions will be up to 76 centimeters. It is to be filled up with mercury. The level of mercury at normal atmospheric conditions will be, and it will be 76 centimeters. All this is mercury. It consists of, all this is mercury. It is mercury. This is mercury. The level of mercury in barometer will be up to 76 centimeters at normal atmospheric conditions. It is. This height is 76 centimeters. This height would be 76 centimeters. The height of level of mercury will be 76 centimeters. This is. The level of mercury in barometer will be up to 76 centimeters. This will be 76 centimeters. This is 76 centimeters. This is itself is known as 1 atmosphere pressure. 1 atmosphere pressure or 1.03 into 10 to the power of 5 pascals. 10 to the power of 5 pascals. It is. It is also known as 1.03 bar. 1.03 bar. So that is nothing but 1 atmosphere 76 centimeters. It consists of a thicker glass tube of length approximately 1 meter, but diameter 1 centimeter. From the open end, the glass tube is filled up with mercury. After filling up with mercury, then it is closed at one end, which is closed at one end and opened at the other. From the open end, it is to be filled up with mercury in the glass tube. Then afterwards, by keeping a thumb, by supporting a thumb, it is inserted in mercury containing another container. Now the thumb is taken out. Now the level of mercury in barometer will be 76 centimeters. That is itself is known as, sir, itself it is known as, that is known as 76 centimeters, known as 1 atmosphere pressure. Hello? 1 atmosphere pressure. That is known as 1 atmosphere pressure. That is known as 1 atmosphere pressure. So, and also 1.03 into 10 to the power of 5 pascals or 1.03 bar. So then 1.03 bar. Therefore, 1 atmosphere pressure, that is known as 76 centimeters. That is also known as 1 atmosphere pressure. That is also known as 1.03 into 10 to the power of 5 Pascal. Pascal is the name of the scientist. Pascal. That is also known as 1.03 bar. 1.0. It is clear that 1 bar is equal to, that is 10 to the power of 5 pascals. 1 bar is equal to 10 to the power of 5 pascals. That is 1 bar is equal to 10 to the power of 5 pascals. All this. So suppose you go up from the surface of the earth, what about the atmosphere? Based on altitude, if you go up from the surface of the earth, the pressure will be decreased. Pressure is decreased. Why? Because this atmospheric layers will be depleted. Those depleted layers will not exert that much pressure. Therefore, due to decrease in pressure, the level of mercury in barometer also decreases. So for every 273.7 meters, the level of mercury in barometer decreases by 2.54 centimeters based on altitude. Therefore, the level of mercury in barometer decreases. Suppose we go exactly 273.7 meters, 273.7 meters, there the level of mercury in barometer would be 76. It is decreased by 2.54 centimeters. That is 76 minus 2.54. It will be 73.46 centimeters. Again from there, if we go again 272.7 meters, the level of mercury in barometer again decreased by 2.54 centimeters. Therefore, for every 270.7 meters, not 273, it is 272. 272, that is every 272. 272, every 272.7 meters of height from the means level, the level of mercury in barometer can be decreased by 2.54 centimeters. Suppose we go up from the surface of the earth, what happens? We go up from the surface of the earth, then what happens? We go up from the surface of the earth, the pressure will be, if you go up from the surface of the earth, the pressure will be decreased. Pressure will be, increased. Pressure increased. Sorry, if you go up from the surface of the earth, pressure is decreased, right? Then if you go down from the surface of the earth, what happens? Go down from the surface of the earth. So based on valley, based on depth, what happens? Suppose we go into the valley. The place which is below from means level is known as valley. The pressure will be increased. We go into the valleys or the place which is below from means level, the pressure will be increased. At which rate it can be increased? At which rate? For every 273.7 meters of depth from the means level, the level of mercury in barometer can be increased by 2.54 centimeters. For every 272.7 meters of depth from means level, the level of 272.7 meters of depth from means level, 272.7 meters of depth from means level, the level of mercury in barometer can be decreased by 2.54, increased by 2.54 centimeters. Suppose we go down to a place which is below 272.7 meters from the means level, like valley. There the pressure would be 76, increased by 2.54, that is 78.54 centimeters. Again from there, if you go again by 270.7 meters of depth, the level of mercury barometer can be increased by 2.54 centimeters. Then what are the uses of barometer? Let us learn about uses of barometer. Uses of barometer. Barometer. Number one. Barometer can be used First one for determining the atmospheric pressure. For determining atmospheric pressure. Atmospheric pressure can be determined by using this barometer. It consists of a thicker glass tube by filling it with mercury. So we can find out, suppose in Hyderabad, how much is pressure, we can find out. So atmospheric pressure, if it is 76 or more than 76, we can find out. Usually, Hyderabad is above from mean sea level, the pressure will be relatively less. It will be less than 76 centimeters. And also, second use is, it is used to determine the depth of the height or the depth of the place from the mean sea level. Height of the place or depth of the place from mean sea level can be determined. Height or depth of the place from the mean sea level can be determined. Suppose what happens if we suppose Hyderabad is on plateau land. How far is from the mean sea level we can find out. So if we conduct this experiment, barometer experiment, here the atmospheric pressure will be, level of mercury will be less than 76 centimeters. Let it be 71 centimeters, means 5 centimeters decrease. If 5 centimeters decrease, what is the height of Hyderabad from mean sea level? We know that if level of mercury is decreased by 2.54 centimeters, 2.54 centimeters, the height would be 272.7 meters. If it is decreased by 5 centimeters, then what would be the height? We can find out. That is more than 270.7 meters. That's why more by less. 5 by 2.54 centimeters into 272.7 meters. We can find out the height of Hyderabad from mean sea level. And also depth also we can find out. Third one. Depth of place from mean sea level can be also determined. Depth of the place from mean sea level can be determined. Depth. Third one is depth we can find out. Depth of place from mean sea level. Suppose if a valley, how far is depth we can find out. So valley, the pressure will be more. In valley, pressure will be more, relatively more. Therefore, the level of mercury in barometer will be more than 76 centimeters. Let it be 78 centimeters. Actually 76 centimeters. So 78 minus 76 is 2 centimeters. 2 centimeters increase. Then what is the height of that place from mean sea level? 2 centimeters. So we know that if 5 centimeters decrease, then 278.7 meters. That is. Then how much it will be, we can find out like that. And also fourth one is the gradual fall of mercury in barometer. Gradual fall of mercury in barometer indicates cyclone or star. Gradual fall of mercury in barometer. Gradual fall of mercury in barometer. Gradual fall of mercury. In barometer. Meter indicates rainfall. Gradual it is falling means it will indicate rainfall. And next one is the sudden fall of mercury in barometer indicates cyclone. Fifth one, sudden fall of mercury in barometer will indicate cyclone or star. Sudden fall of mercury. Mercury Hg will indicate cyclone or star. Cyclone or star. The sudden fall of mercury in barometer will indicate cyclone or star. Then what is the range between this gradual fall and rainfall? Similarly, sudden fall and this one. Whenever the mercury is falling gradually means the level of mercury is falling gradually means the low pressure zone is going to be created. Whenever the low pressure zone is created, then the rains will occur. How does it occur? Low pressure means that due to the atmospheric conditions, the percentage of air will be less in the atmosphere relatively. If the in the atmosphere, if percentage of air is less, then what happens? then the atmospheric layers will blow down, will move down. So therefore, the atmospheric layers will become so thicker and thicker. Now, so much of atmosphere, so this atmosphere will be visible at the time. The visible atmosphere is known as clouds. What are the clouds? Clouds are nothing but atmosphere, the visible atmosphere. Whenever the air is relatively less, or air is decreased, or low pressure is formed, or depression is formed, then the atmosphere layers will get closer to each other. In the atmosphere also, air, water vapor, and dust particles will be there, but air will be relatively less. So the remaining particles will be more, that is, water particles will be more, since air is less. So water is more. And the specific property of water is that the water particles will attract with one each other. The force is known as cohesive force. For example, take a fresh leaf or a smooth plate, steel plate, or any plate, whatever you use in kitchen, or plastic plate you can take, or ceramic plate, or fresh leaf. So place a single droplet on the plate. Then try to separate by using tip of the needle or tip of the pen. Single droplet of water. Try to separate it two. We can't. Just if you try like that, just it elongates and regains back its original shape. It's not possible separation of one water droplet into two. Why? Because there will be attraction force between the water molecules themselves. That's why it's not possible. So there is an attraction force between water molecules themselves. That's why it's not possible to separate one single droplet into two. But similarly, whenever two neighbor drops are there, water drops on the same smooth plate, if we join them immediately, they stick, they join and form a large droplet. So it is not possible separation of a single droplet into water droplet into two, but whenever two water drops are joined, they get together for forming a larger drop. Why? Because there is an attraction force between water and water molecules. That's why they are joined within a short period of time. Why is it not possible separation of one water particle into two? Why? Because so there will be attraction force between water particles themselves. Such kind of force known as cohesive force. Therefore, what I mean to say is the water particles attract with one each other. Therefore, in clouds also, whenever low pressure is formed, then the air will be relatively less. Therefore, in the atmosphere, the water particles will be relatively more. So these water particles attract with one each other. That is called due to cohesive forces. Therefore, the water particles get closer to each other. Therefore, the clouds will become thicker, and moreover, the clouds are getting over to the earth, getting down to the earth due to lesser air. So many thicker clouds are found, and the height of the clouds will be relatively less, and the clouds will be so thicker, and they found dark or black. So this is then whenever the water particles are increased more, then they fall to the ground. These water particles will fall to the ground. So these water particles will fall to the ground. That's it. Therefore, such consequences will take place during rainfall. But whenever we conduct this experiment at that time, the water particles, though the level of mercury barometer gradually falls in this. The level of mercury barometer gradually falls, right? Slowly it falls. Therefore, the gradual fall of mercury barometer will indicate cyclone or storm. Then, what about sudden fall of mercury barometer indicates? The sudden fall of mercury barometer indicates cyclone or storm. Usually, this cyclone or storm will be. It is the origin for cyclone or storm will be originated in the sea. It is originated in the sea. It will be originated in the sea. In sea also sometimes the low pressure zone is formed. Then that is nothing but air escapes from there. That is called relatively less pressure. Then the air is the elastic media. Wherever the air is not there, from other parts of the air blows from high pressure zone into low pressure zone. Air blows from high pressure zone into low pressure zone. So therefore, if it is wherever the low pressure is formed, wherever the low pressure is formed, the low pressure zone is formed like this. Wherever the low pressure zone is formed, and like this is called low pressure zone is formed. But the specific property of air is that here no air. In this circle, there is no air. If there is no air in this circle, then comparing to the other parts, here air is less. Now, from other parts of the the air blows towards this zone, and from all parts, the air tends to blow into this part, and it will try to get into the low pressure zone, but it will not go into the low pressure zone. It will not go into the low pressure zone. As a result, and it will make circles over that. It will make circles over that. This air will make the circles over this, and it will not enter into the low pressure zone. And this is called, and this is called, and this is called depression. Now, this will blow. This low pressure zone, the diameter of this zone will be approximately 100 kilometers. Approximately 100 kilometers. It need not be exactly 100 kilometers, but usually it will be around 100 kilometers. That mark, it will be about 100 kilometers. 100 kilometers. And this low pressure zone will move towards the low pressure zone. Therefore, now, especially sometimes 70% of the cyclones start in the sea, end in the sea, and only 30% will move towards the land surface. We will talk about those cyclones, and with those cyclones, is there any are there any advantages or only disadvantages? With the cyclones, both the advantages and disadvantages are there. Therefore, these cyclones sometimes move towards the land surface. Whenever they are crossing the seashore, now we call it as it is termed as cyclone. Before that, it is known as only low pressure zone. Only low pressure zone. So now, about 50 centimeters of rainfall will occur. If during this cyclone, now whenever it is the air is blowing towards this circular path, large quantity of water is carried into the atmosphere. Large quantities of water is carried into the atmosphere. Now, so thicker layers will be found on the surface of the sea. Thicker layers, thicker clouds, water clouds will be formed on the sea. So therefore, now this atmosphere, now the 50 centimeters of rainfall will occur. Now, during this formation of this cyclone, if we conduct the experiment, this barometer experiment, the level of mercury in barometer suddenly falls. Therefore, the sudden fall of mercury in barometer will indicate cyclone or star. Cyclone or star. The sudden fall of mercury in barometer will indicate cyclone or star. Then cyclone or star. The sudden fall of mercury in barometer will indicate cyclone. Then the effect of cyclone will be up to 500 kilometers. These are the questions asked in different competitive examinations. How much of rainfall will occur? That is 50 centimeters. The effect will be 500 kilometers from the seashore. Wherever the cyclone crosses the sea, from that place, it will be 500 kilometers. The normal effect will be up to 500 kilometers. But severe effect will be up to 150 kilometers. Severe effect will be up to 150 kilometers, whereas normal effect will be up to 500 kilometers. Very nearby the sea, the effect will be too large. Too large. This is then what is the normal lifespan of a cyclone? Even though cyclone doesn't have particular uh, lifespan, but the normal lifespan of cyclone will be 6 days. We should say 6 days. All these are the questions asked in different competitive examinations. It will be 6 days. Most of the, that is 90 to 95% of cyclones will stay 6 days. Some cyclones may end before 6 days, some cyclones may end after 6 days. But 90% of the, an average 90% of the cyclones will last for 6 days. But in the year 1989, a cyclone was occurred in Pacific Ocean in 1989, super cyclone, and it was lasted for 31 days. 1989 super cyclone, it was lasted for 31 days, that is 1989, August 30, August 11th to then September 11th. August 11th to September 11th was lasted for 31 days. This was the long lasting cyclone so far in the world. This is about cyclone. We conduct this experiment during formation of the cyclone. The rain will, then the level of mercury barometer suddenly falls. Then next one is this is end of this chapter. Let us start the other chapter. Just let me take some drinking water. I will get in within 1 minute. Okay, welcome back. Let us start the other topic called heat. Heat. Then what is heat? Let us learn. Heat. Heat is one of the forms of energy which provides a sensation of hotness. According to law of conservation of energy, energy is neither created nor destroyed, but it can be changed from one form to the other. If the energy disappears in one form, then it may also appear in the other form. This is called the law of conservation of energy. So, according to law of conservation of energy, the energy doesn't have particular form. Energy has so many forms. One of the forms is heat. Therefore, heat is a form of energy which provides a sensation of hotness. So, according to law of conservation of energy, energy is neither created nor destroyed, but it can be converted from one form to the other. For example, if you switch on the fan, the electrical energy can be converted into, that is mechanical energy. It runs the fan. If switch on the in bulb or tube light, electrical energy can be converted to light energy. In heater or iron box or automatic rice cooker, electrical energy can be converted to heat energy. Then this heat energy is converted to which form? It is converted to work. Similarly, in bulb, electrical energy can be converted to light energy, no? Then light energy is converted to which form? It is converted to work. Suppose in the night, we are going on writing or reading or learning something. Without light, we can't. So, means it helps us in doing our work. That is called, we call it as it is converted to work. It is playing its role in our work. Some part of it also converted into work. So in our work also, its use is also there. Therefore, it's converted to work. If you switch on the fan, that electrical energy can be converted into mechanical energy, then mechanical into electrical energy. Therefore, energy can be converted from one form to the other, but energy is neither created nor destroyed. Therefore, the total sum of energies in all the forms of the universe always remain constant. The total sum of the energies in all the forms in the universe will always remain constant. The total sum of the energies in all the forms of the universe always remain constant. This is known as law of conservation of energy. Therefore, heat is also one of the forms of energy. Heat is also one of the forms of energy. Therefore, it is heat is also one of the forms of energy, which provides a sensation of hotness. It provides the sensation of hotness. Sensation of hotness. Heat is one of the forms of energy which provides a sensation of hotness. And according to law of conservation of energy, energy is neither created nor destroyed, but it can be converted from one form to the other. Converted from one form to the other. This is known as the law of conservation of energy. Then, what are the units for heat? Units for heat. CGS units. In CGS system, it can be measured in erg or calorie. It can be measured in calorie. In MKS unit, the heat can be measured. It is measured in joules. So in CGS system, it can be measured in erg or calorie, whereas in aqueous system, it can be measured in joule. And we know that 1 calorie is equal to 1 joule is equal to 10 to the power of 7 x. 10 to the power of 7 is nothing but 1 crore. Similarly, 1 calorie is equal to 1 calorie is equal to 4.182 joules. 182 joules are approximately equal to 4.2 joules. Approximately equal to 4.2 joules, 1 calories. So 1 joule is equal to 10 to the power of 7 x. 10 to the power of 7 is nothing but 1 crore. And 1 calorie is equal to 4.182 joules. So this 4.2 joules is also known as mechanical equivalent of heat. mechanical equivalent of heat. Mechanical equivalent of heat. Mechanical equivalent of heat. So MEH. Mechanical equivalent of heat. Why? Because if the calorific value of any normal carbohydrate will be this much. The calorific value of any normal carbohydrate will be this much. The calorific value of any normal carbohydrate will be this much. How much it will be? It will be approximately calorific value of any normal carbohydrate. It is also known as starch. Example for starch is rice. Its calorific value will be, that is 1 calorie per gram. Or it is also known as 1 calorie per gram is also known as 4.182 joules. Or it is also known as 4.2 joules. So that is 1 calorie per gram or 4.2 joules per gram, we can say. Or 4.2 joules per gram. Means if we take 1 gram of starch or carbohydrate like rice, by burning in the calorimeter, in the device called calorimeter, in the device called calorimeter. So it by burning 1 calorie of energy per gram or 1 joule per gram of energy can be. If you take 1 gram of rice or any carbohydrate by burning in the calorimeter, then 1 calorie of energy can be liberated or 1 joule of energy can be liberated. This is known as the calorific value of carbohydrate. Like this, all the materials, all food materials will be having some calorific values. Even we can find out the calorific value of coal by burning in this device called calorimeter. Calorimeter is nothing but just like a container, just like a vessel, cooking container. It can be burned in that, any coal, any rice, dal, anything. We can find out the calorific values. The calorific values of all food materials can be determined by like this. So coal can be also determined, but the purpose will be different. Coal, by burning the coal in thermal power stations, they are able to convert it to electrical energy. But rice we are taking it as a food. That means if we take 1 gram of rice as a food, we get 1 calorie of energy or 4.4 joules of energy. So, like this, all food materials, their calorific values can be determined. Our nutritionists or doctors will determine, our nutritionists will determine the calorific values of all the food materials by using such device called calorimeter. In calorimeter, by burning in that. By burning in that calorimeter, their calorific values can be determined. Suppose 1 gram of rice, how much of calorific values? We can find out by burning 1 gram of rice. So that is also rice, dal, cereals, pulses, vegetables, and curry leaves, all, and even non-vegetable materials like chicken, mutton, fish, and also vegetables and fruits. By burning them in this calorimeter, we can find out their calorific values. Therefore, calorimeter is a device used to determine the calorific values of the materials. Now, next one. Let us learn about thermometer. What is a thermometer? Thermometer is a device used for measuring temperature. It is measuring. The device meant for measuring temperature. Thermometer is a device used for measuring temperature. Can be used for measuring temperature. Usually, we use 3 types of two types of thermometers. Then in general, in all the thermometers, what do we use? Thermometers. In thermometers, what do we use? In thermometers, in general, it is filled up with which liquid can be used in thermometers. In general, we use mercury. In all the thermometers we use, usually mercury can be used. Mercury can be used. Why mercury is used? Why? Because due to the specific properties of mercury, in general, we use mercury. What are the specific properties of mercury? Due to the specific value, specific properties of the mercury, in general, we use mercury. What are the specific properties of mercury? So, what are the specific properties of mercury? Mercury is the only metallic element which is in liquid state at room temperature. It is only metallic element which is in liquid state at room temperature. Only metallic element which is in liquid state at room temperature. In liquid state at room temperature. Which is liquid state at room temperature. So far, we have more than 100 elements today. After more than 100 elements today, only two elements are in liquid state. What are they? Bromine and mercury. But bromine is non-metal, whereas mercury is a metal. Mercury is the metal, it is an element which is in liquid state. It has specific property, no other element. Today we have more than 100 elements today. 100 around total number of elements today is 118, 118. After 180 elements, only two elements are in liquid state. One is bromine, the other is mercury. Then what is the basic difference between bromine and mercury? Bromine is non-metal, whereas mercury is a metal. Mercury is the element, it is the metal which is in liquid state. Therefore, mercury is the only metallic element which is in liquid state at room temperature. Only metallic element which is in liquid state at room temperature. And second one is it has highest coefficient of expansion. Mercury has highest coefficient of expansion. Highest coefficient of expansion. Means for a minimum rise in temperature, it expands a lot. For a minimum rise in temperature, it expands a lot. And third one is its highest density. Density of mercury will be D is equal to 13.6 gram per cubic centimeters. 13.6 gram per cubic centimeters. Whereas density of water is only 1 gram per cubic centimeters. Density of water is only 1 gram per cubic centimeters. That is. Means if we take 1 centimeter cube of mercury, 1 centimeter cube of water, its mass is only 1 gram. Otherwise, if we take same 1 centimeter cube of mercury, its mass will be 13.6 grams. Its mass will be 13.6 grams. Its mass will be. 13.6 grams. Its mass will be. Therefore, it has highest coefficient of expansion and it has highest density. And fourth property is it will not stick to the glass, won't stick. Mercury won't stick to the glass. Will not stick to the glass, mercury. Stick to the glass, but easily slides. Stick to the glass, but easily slides over the surface of the glass. Will not stick, but easily slides over the surface of the glass. Easily slides. And it is clearly visible in the glass. Clearly visible in the glass. clearly visible in the glass. Mercury is clearly visible in the glass. So suppose if we keep in a transparent bottle water, the level of water is not clearly visible. Why? Because water is transparent material. Bottle is also transparent one. That's why it is not clearly visible. But even if you keep in a narrow glass tube, the mercury will be clearly visible even from farther distance. Even from farther distance, it is clearly visible. Even if you look up from the farther distance, it's even if it is up, it is clearly visible. The glass tube, wherever. So why? It's clearly visible. And the next one is by using mercury, we can measure the temperature ranging from. By using mercury, we can measure the temperature from minus 39 degrees Celsius to minus 39 degrees Celsius to 359 degrees Celsius. We can measure minus 39 to 357 degrees Celsius. Why not less than minus 39? Mercury freezes at minus 39 degrees Celsius. Why not more than 357? So minus 39 to 357, that is not 9, 357, that is 357. That is minus 39 degrees Celsius to 357 degrees Celsius can be measured. Minus 39 to 357 degrees Celsius. Why not less than minus 39? At minus 39 degrees Celsius, mercury freezes. Why not more than 357? At 357 degrees Celsius, mercury boils. Just like the water boils at 100 degrees Celsius, mercury boils at 357 degrees Celsius. Then why not less than minus 39 degrees Celsius? So mercury freezes at minus 39 degrees Celsius. Now, in general, we use two types of thermometers. We use two types of thermometers. Usually, we use two types of thermometers in general. Two types of thermometers. Two types of thermometers we use. Two types of thermometers we use. So they are number one, Celsius thermometer. Celsius thermometer. Number two, Fahrenheit thermometer. Fahrenheit thermometer. Celsius thermometer. Number two, Fahrenheit thermometer. Then Celsius thermometer was constructed by Andreas Celsius. Who constructed Celsius thermometer? Asked in some competitive examinations. Andreas Celsius. It was constructed by Andreas. Andreas Celsius. It was constructed by. Whereas Fahrenheit thermometer was constructed by GD Fahrenheit. GD Fahrenheit. GD Fahrenheit. Celsius thermometer was constructed by Andreas Celsius, whereas Fahrenheit thermometer was constructed by GD Fahrenheit. By using Celsius thermometer, the temperature can be measured in degree Celsius. Degree Celsius or degree centigrade. Degree Celsius or degree centigrade. C for centigrade, C for Celsius. We can say anything. Whereas by using Fahrenheit thermometer, the temperature is measured by Fahrenheit. So in Celsius, by using Celsius thermometer, the temperature is measured in degrees Celsius or degrees centigrade. Actually, it should be measured in degrees centigrade. But we are also including the name of the scientist. Degrees centigrade. No difference. Degree centigrade, degree Celsius, no difference. So therefore, then by using Fahrenheit thermometer, temperature is measured in degree Fahrenheit. Then what is the relationship between degree Celsius and degree Fahrenheit? Relationship between degree Celsius and degree Fahrenheit. Relationship. Relationship between degree Celsius and degree Fahrenheit. the relationship between degree Celsius and degree Fahrenheit. Degree Fahrenheit. What is the relationship between degree Celsius and degree Fahrenheit? Degree Fahrenheit. What is the relationship? What is the relationship between these two? Let us try. So now the relationship between degree Celsius and degree Fahrenheit is, that is C by 100 is equal to F minus 32 by 9, 32 by 180. This is the relationship between degree Celsius and degree Fahrenheit. So that is C by 5 is equal to C by 5 is equal to C by 100 is equal to, that is C by 100 is equal to F minus 32 by F minus 32 by 9, 32 by 180, that is. This is a relationship between degree Celsius and Fahrenheit. So by it is clear that degree Celsius is divided into 100 equal parts, and Fahrenheit is divided into 180 equal parts. This 100 Celsius, that is Celsius thermometer. So by using Celsius thermometer, there will be 100 equal parts divided by 100. This scale is divided into 100 equal parts, and Fahrenheit scale is divided into 180 equal parts. It is clear that divided by 180 means 180 equal parts. And also it is clear that C is equal to F minus 32 means this Fahrenheit is 32 degrees units forward. 32 units forward. Therefore 32 units forward. We can use this equation as it is, or by using simple mathematical equations, we can simplify this one. So we can, this one here 0 and 0 gets cancelled here. This 0 can be gets cancelled, and here 0 can be gets cancelled. This is 5, 9, that is 2 5s we can get here, and 2 9s we can get here. This is 2 9s. 2 9s. So that is also, that's why it is also written as C by 5 is equal to F minus 32 by 9. C by 5 is equal to F minus 32 by 9. Is equal to F minus 32 by 9. So by using this equation, we can convert degree Celsius to degree Fahrenheit, or degree Fahrenheit to degree Celsius. Now let us make a note here. Note. Number 1. What is the melting point of ice? Melting point of ice. Melting point of ice is, that is 0 degrees Celsius. 0 degrees Celsius or 32 degree Fahrenheit or 273 Kelvin. That means 0 degrees Celsius is equal to 32 degree Fahrenheit is equal to 273 Kelvin. So means it is clear that 0 degrees Celsius is equal to 32 degree Fahrenheit. If it is given, what is the melting point of ice? We know that it is 0 degrees Celsius. Then what is the melting point of ice Fahrenheit. It is 32 degree Fahrenheit. What is the melting point of ice in Kelvin? It is 273. Whatever he asks in, we should answer. And second point is, what is the boiling point of water? Second one, the boiling point of water. Boiling point of water is 100 degrees Celsius. Boiling point of water is 100 degree Celsius, or it is 212 degree Fahrenheit. 212 degree Fahrenheit, or it is also 373 Kelvin. 373 Kelvin. Whatever he asks, now we should answer. Now, whatever he asks, we should answer. That is always, for converting Celsius into Kelvin, we should add, that is 273. We should add 273 for converting. Relation between these two is. So suppose if it is, what is this? According to Charles' law, volume occupied by the given mass of the gas will be directly proportional to temperature. The volume occupied by given mass of the gas will be always directly proportional to the temperature. Volume occupied will be directly proportional to the temperature or absolute temperature. Volume occupied will be directly proportional to temperature. By increasing temperature, volume increases, and decreasing the temperature, volume decreases. Increasing temperature, volume increases, and by decreasing the temperature, volume decreases. Volume decreases. So, volume of the gas. So, therefore, the temperature of the gas will be 0 at minus 273 degrees Celsius. The temperature of any gas will be 0 at minus 273 degrees Celsius. That is considered to be 0 Kelvin. 0 Kelvin. So therefore, Celsius will be always 273 less than Kelvin, or Kelvin will be 273 more than Celsius. Therefore, for converting Celsius into Kelvin, T degrees Celsius, we should add 273 for Kelvin. So that is 273 for getting into Kelvin, 273, and that is in 273, and plus T we can convert. Plus T, that is, now it is in Kelvin. This is in Kelvin. Therefore, for converting, this is a relationship. Always for converting degrees Celsius to Kelvin, we should add 273. For example, what is 10 degrees Celsius? 273 plus 10, 283 we can write. 283, that is. 283, that is. For example, if 10 degrees Celsius is equal to 10 degrees Celsius is equal to 273 plus 273 plus 10, that is 283 Kelvin. That will be 10 degrees Celsius is equal to 273 plus 10 degrees Celsius. That is in Kelvin. That is in Kelvin. So that is nothing but 283 Kelvin. Therefore, for converting into Celsius into Kelvin, we should add 273. Therefore, if for melting point of ice is 0 degrees Celsius, then melting point of ice 0 degrees Celsius, then Fahrenheit 32 degree Fahrenheit, Kelvin 273. Why? Because Kelvin will be always 273 more than Celsius. Similarly, boiling point of water is 100 degrees Celsius and or 212 degree Fahrenheit. In Kelvin, 100 plus 270. For converting it to Kelvin, we should add 273. Similarly, what is the normal human body temperature? Normal human body temperature. Third point. The normal human body temperature. Normal human body temperature is normal human body temperature is 98.4 degree Fahrenheit. 98.4 degree Fahrenheit, or it is 36.9 degrees Celsius. Somewhere it is also given as 37 degrees Celsius. In some textbooks also, since it is approximately 36.9 is nothing but 37 it is given some textbooks. It is given as 37 degrees Celsius. Then, or it is also given that is 273 plus 37 is nothing but 310 Kelvin. 310 Kelvin it is given. That means, so that is nothing but 98.4 degree Fahrenheit. 98.4 degree Fahrenheit is as same as 37 degrees Celsius, is as same as 310 Kelvin. That's 98.4 degree Fahrenheit is as same as 37 degrees Celsius, is as same as 310 Kelvin. All are same. So this is about normal human body temperature is always 98.4 degree Fahrenheit or 37 degrees Celsius or 310 Kelvin. So similarly, the human body temperature will be 37 degrees Celsius. In which season? Somebody will say summer, winter, like that. Always human body temperature will be 37 degrees Celsius in any season, irrespective of the season. Human body temperature will be always 37 degrees Celsius. Now, fourth point is at which temperature degrees Celsius and Fahrenheit are equal? At which temperature degrees Celsius and Fahrenheit are equal? So at minus 40 degrees Celsius and Fahrenheit are equal. At minus 40 degrees Celsius, that is minus 40 degrees Celsius is equal to minus 40 degree Fahrenheit. Minus 40 degree Celsius is equal to minus 40 degree Fahrenheit. At minus 40, both are equal. Degree Celsius is equal to Fahrenheit. Minus 40, all are equal. That is minus 40 degrees Celsius is equal to minus 40 degree Fahrenheit. Both are equal at minus 40. So that is, it is converted. So that means if we convert this one, C by 5 is equal to C by 5 is equal to F minus 32 by 9. That is there now. If we divide here, then this equation is satisfied. These are the questions asked in different competitive examinations. Then next question, the question was given civils and group 1 and also SSC it was given RRB. So many competitive exams. At which temperature the water evaporates? The question was. Which temperature the water evaporates? The question is. The water evaporates. Most of the students will answer 100 degrees Celsius, but 100 degrees Celsius is a wrong answer. The correct answer is at any temperature. Water evaporates at any temperature. For evaporation of water, it doesn't require 100 degrees Celsius. Water evaporates at any temperature. For example, in summer, the water evaporates from all these sources of water. We have studied in lower class geography, high school geography. Water evaporates in summer from all the water sources like sea, oceans, and rivers, even wells and canals. So, in summer, what would be the temperature of water? Not more than 40 to 43 like that. Therefore, 40 to 43. Summer evaporates 42 means it need not. In 42 degrees Celsius, water is able to evaporate means it doesn't require 100 degrees Celsius. Not only summer, suppose in winter, even winter or rain season, place some few drops of water on the smooth plate. Keep it aside for few hours, for 5 or 6 hours. What happens? It disappears. Where it has gone, the water droplets, they can evaporate. Suppose in winter, is it 100 degrees Celsius? Not even 100, not even 30. In night also it will happen whenever the temperature reaches 8 degrees Celsius. Why? Because water evaporates at any temperature. What for boiling it requires 100 degrees Celsius. So whenever we supply the heat of water, let us take some content of water in the container, then keep it on the stove, then lit the stove. If you supply the heat, the particles at the bottom will absorb the heat. They rise up slowly, and like small water droplets are seen after 5 or 6 minutes. So during the course of the time, the water particles will move. Whenever the temperature reaches 100 degrees Celsius, 100% of water particles will be under motion. That is called boiling. But evaporation is not that. So which is reaching from liquid state into gas state. For evaporation, it doesn't require 100. For boiling, it requires 100. Both boiling and evaporation not the same. What we feel is both are the same. Evaporation will be totally different from boiling. Actually, both are the physical changes, but both are not the same. So therefore, water evaporates at any temperature. It doesn't require for evaporation particular temperature. For boiling, it requires 100. Water evaporates at minus 40 degrees Celsius. It evaporates at minus 10, minus 4 also it evaporates, minus 1, 0, 4, 60, 100. But it evaporates more at minus 4 than minus 40, more at 0 than minus 4, more at 1 than 0, more at minus 1 than 0, then more at 4, more at 60, more at 100. More is the temperature difference, more will be the rate of evaporation. Then next one is, at which temperature the water exists both in solid, liquid and gas states. That is, at 0 degrees Celsius, the water exists both in solid, liquid and gas state. Both in solid, liquid and gas states. Solid, liquid and gas states. Water exists both in solid, liquid and gas states. Suppose, let us take some content of ice in the cup, then let us weigh half of the piece of ice. Let us insert a thermometer on ice, which will represent 0 degrees Celsius. Let us insert one more thermometer in the water, that can also represent 0 degrees Celsius. And water exists at solid state at 0 degrees Celsius, liquid state at 0 degrees Celsius. And also evaporates at which temperature? Also at 0. Why? Because water evaporates at all the temperatures, also at 0. Therefore, water exists both in solid, liquid and gas states at 0 degrees Celsius. Therefore, 0 degrees Celsius is also known as the triple point of water. What is triple point of water? At 0 degrees Celsius, the water exists both in solid, liquid and gas states. The water exists both in solid, liquid and gas state at 0 degrees Celsius. Therefore, 0 degrees Celsius is known as the triple point of water. Now let us learn some other thermometers that we use. 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 Thermometer and then some other thermometers that we use. thermometer and measurable temperature. Now let us make a prepared table here. Thermometer and measurable temperature. Thermometer. So, and let us take mercury thermometer. Mercury thermometer number 1. Different kinds of thermometers. Mercury thermometer. Mercury thermometer. By using mercury thermometer, we can measure the temperature from minus 39 degrees Celsius. We can measure minus 39 degrees Celsius to 357 degrees Celsius. We can measure. Minus 39 degrees Celsius to 357 degrees Celsius. 57 degrees Celsius. Why not less than minus 39? Mercury freezes at minus 39. Why not more than 357? It boils at 357. Then alcohol thermometer. Alcohol thermometer. We can measure minus 114 degrees Celsius to 96 degrees Celsius. Minus 114 degrees Celsius to 96 degrees Celsius. Why not less than minus 114? It boils it freezes at minus 114. Freeze at why not more than 96? It boils at 96. Then hydrogen vapor thermometer. Hydrogen vapor thermometer. Hydrogen vapor thermometer. Vapor thermometer. Thermometer we can measure. We can measure, that is minus 210 degrees Celsius. We can measure to 500 degrees Celsius. And by using alcohol thermometer, we can measure minus 114 to 96 degrees Celsius. No? So in cold places like Jammu and Kashmir and Darjeeling and Siachen, the coldest vast part of the world, which is in Jammu Kashmir, that is in India, that is we can measure only alcohol thermometer there. We can't use our mercury thermometer. And hydrogen vapor thermometer. And next one is nitrogen vapor thermometer. Fourth one. Nitrogen vapor thermometer. Vapor thermometer. We can measure minus 258 degrees Celsius to we can measure 1000 degrees Celsius. We can measure. Then fifth one is helium vapor thermometer. Helium vapor thermometer, by using which we can measure minus 273 degrees Celsius to 2000 degrees Celsius. We can measure minus 273, and lowest temperature can be measured by using this. And thermoelectric thermometer, thermoelectric thermometer, electric thermometer. Thermometer, we can measure 2000 degrees Celsius to 3000 degrees Celsius. We can measure 2000 to 3000 degrees Celsius. We can measure 2000 degrees Celsius to 3000 degrees Celsius. And next one is pyrometer. Pyrometers are used in industries. Seventh one, pyrometer. 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 By using pyrometer, we can measure. So that is 0 to degrees Celsius to 6000 degrees Celsius. 0 to 6000 degrees Celsius we can measure. It can be used in industries. Then optical pyrometers. Eighth one. Optical pyrometer. Pyrometer. It can be, by using optical pyrometer, we can measure the temperature up to 0 degrees Celsius to 20,000 degrees Celsius temperature can measure. 20,000 degrees Celsius. It is used for measuring the temperature of sun and other stars. And also, clinical thermometer can be used for human body temperature. Clinical thermometer. Eighth one, clinical thermometer. And can be used for measuring human body temperature, and temperature will be represented on that 95 degree Fahrenheit to 110 degree Fahrenheit. The temperature can be mentioned on that. Then last one is, ninth one is 6 minima and maxima thermometer. 6 is the name of the scientist. 6 minima and maxima thermometer, by using which we can measure the temperature, that is minimum and maximum atmospheric temperature. Maximum atmospheric temperature can be used. 6 is the name of this. Okay, with this we have finished this chapter. Let us continue the other chapter in the next class. Okay, thank you.